Hey, happy Friday, everybody. We made it through our first full week of AP Computer Science A live lessons. My name is Rob Schultz, and let me flip the slide there. There we go. My name is Rob Schultz, and I teach at Bellbrook High School in Bellbrook, Ohio.
And I'm Jill Westerlund from Hoover High School in Hoover, Alabama. We are so glad you're with us today. Hope you've been here many days, but if you can see from this map, we are respectively in Ohio and Alabama. And then here's our map. I haven't updated the whole world map in a few days, so I'll do it this weekend. So if some of you have sent us something that lets us know where you are, an asset of some sort, an artifact, then we'll populate that. I think we do have some Oregon, and I think some other, maybe Ontario or some other.
And I wanted to jump in real quick and send a special little shout out to Mrs. Wyman's class in Phoenix, Arizona. I received an email from Mrs. Wyman saying that our live lessons happen to be synchronized to their actual kind of virtual class time.
Wow.
So they've been kind of tuning in their virtual class. So welcome to Mrs. Wyman's class in Phoenix, Arizona.
That's good. And I heard from my Hoover kids today. We had a little class meeting, and several of them are watching. So shout out to you, Buccaneers.
Oh, good deal.
Hoover. So we got our information today. It's April the 3rd. Time is ticking right by. So here is, I'm going to give you a few slides here with some exam information. You do need to go to AP Central and click on the banner at the top with the information about the exam. I've snipping tooled several things related to CSA, but I want to point you to go to AP Central too. Always consider that your source, and we've pulled from that and consolidated it here. So you're going to have 2 AP questions, and we'll talk about the date in a minute, but it's going to be May the 15th, which was your exam date anyway. That was the same day we were already shooting for and working toward all year. So that flag in the sand has not changed. Question number 1 that you'll be presented with is going to be from Array or ArrayList, and it's the former, what we would have called and talked about all year as free response question 3. And you can read the box that I've snipped there. You'll have 25 minutes to work on that question, and then 5 minutes to upload your completed item, and we'll kind of break that down a little bit more. And that question will be worth 65% of the total AP score that you're working to get. After you submit question 1, you'll be presented with question 2. And it will be on methods and control structures, which is a lot of what we've spent some time talking about. And we're going to be zeroing in on these 3 topics, really. I guess you could say 4, but array, 1D array, ArrayList, and then methods and control structures. So question 2 will come after question 1. You will not be able to go backward to question 1. So once you're at question 2, that's your full focus. You'll have 15 minutes to do that question and a 5-minute upload. And it's worth 35%. And it's the question that we would have talked about all year from the course and exam description as being question 1 that you've prepared for. So that's slide number 1. And then on the next slide, our test date, of course, like I said, is May the 15th. That's a Friday. So I think it's 6 weeks from today, if I did my calendar right earlier today. And you see the times. So Hawaii, Alaska, be morning for you, all the way over to Central Time where I live and Eastern Time where Mr. Schultz is. So everybody, all of you, and if you are in India, I know we have Uma from India and we have Ricardo from El Salvador. You got to fit, I think El Salvador is probably Central Time, but I don't know. But I know what India is. So you'll have to figure out what that time is, because everybody's going to be taking their CSA exam at the same exact time and uploading it. And then there's a box about the timing, and it's a little bit of what I just said. And then other course information. And we're going to start kind of a new little segment on Monday. I'm going to use TV terminology, not that we're on TV, but it's like TV. So we'll be adding a feature on Monday with some type of specific strategy that, and I'm going to work on this, and Mr. Schultz is working on it, and we're brainstorming now about what are some things that you need to be able to do to accomplish this exam well. and one of them is related to this other course information. An IDE, which would be JGrass, JDoodle, Java Doctor, Doctor Java, whatever it's called. Notepad++ can be an editor. That might be some way that you work. Is not required, but it does say that you won't have an advantage if you use one, but you can use one. So if you're comfortable working in JDoodle, if you've been doing that with us along on your tablet or your phone, or if you're, using whatever editor you used at school, and you're going to be able to use that. So we're going to start working on strategies of how do I get that code and then get it to where I can submit it. We're going to have to read more about that. Mr. Schultz and I are, but
we'll figure that out.
That's right. But
Yep.
You also have the option to write your code on paper and grab it as an image and submit it that way. So we're going to begin to kind of scaffold you towards strategies for that. And I know some of the teachers, y'all are watching us, we're very thankful for that, and we're honored to represent you. So we'll all be thinking of that and kind of working toward that vein. So don't worry about that yet. We got 6 weeks to get there. Test security is obviously something that College Board has spent a lot of time thinking through and figuring out. I've put the link in there. It's not really a link, but I've given you the path. You're going to go to AP Central Coronavirus Updates, and then there's a whole section on exam security. What I need you to plan right now for is you're going to do your own work, and you're going to do the best work, and you're going to manage your time, and you're going to turn it in. So don't start thinking now about outsmarting the fox.
No, being sneaky.
Sit there and do your work by yourself. I told my class this morning, I want y'all to be in a room with the door closed, alone, have your open notes, and we're probably going to work on that over these 6 weeks as well, and have your little system ready and just walk in there and own it. So that's our plan. And if something happens on May the 15th or that date, is got a conflict for you, the makeup date will be June the 3rd. So I think there's one more little note. This is from the course and exam description. And I threw this in because I want you to begin to notice, and your teachers probably talked to you about this. There are 3 verbs that are used on free response. And we're going to begin next week mapping free response every single day, along with these topics of array, ArrayList, methods, and control structures. But the word assume has a special meaning. Assume, complete, and implement/write. So we will be coming back to these. We may not always come back to all the exam particulars every day, but these verbs need to mean something to you. And I'll probably add this slide as an image in the journal notes section so that you can learn those, because you're going to want to be able to read the question. So that's our exam update, but please go to AP Central and read everything for yourself. Today, we're talking about recursive searching and sorting, particularly sort and particularly merge sort. So Mr. Schultz is going to, I think, take it away, right?
Yep. We'll jump in.
All right.
Okay, so for our warm-up, yesterday I mentioned that one of the things I would show you today was just very quickly what you might, I'm going to show you what you might see if you get into Coding Bat to do some practice problems and you've never used Coding Bat before. Okay, so the first thing I'm going to say, I did have this extra in here that I forgot about. The other thing that we suggested was maybe going out and watching, just for fun, some of the sorting algorithm visualizations that are out on YouTube. They're kind of fun, and they show you different ways to look at different algorithms. But to get back to Coding Bat, I'm going to preface this by saying that as a teacher, I find it very, very, I'm going to say irritating is probably the best word. When I assign my students a project using an online resource, and then I find that somebody somewhere has posted the answers. Okay, so the first comment I would make is please avoid posting answers for the sake of all of the teachers out there that like to use online resources. Please don't post answers online. The second part of that is that I was reluctant to show you a solution in CodingBat because I don't want to break my own rule. I don't want to post an answer. But then I realized that if you go to the recursion section under Java in CodingBat, the first two questions are just kind of warm-up questions that they will show you a hint or show you the solution for those problems. So I'm really not giving anything away by posting my solution. Anybody can go to this specific problem and see the solution to it if you click that button. So, so if you don't want spoilers, you might want to fast forward a little bit if you're watching this recorded. But I am going to show just a quick solution just so that you can kind of see how CodingBat works. And like I said, I don't feel like I'm really giving anything away on this one because the solution's there already. Okay, so for this specific problem, we have a number of bunnies. Each bunny has two big floppy ears, and we want to compute the total number of ears across all of the bunnies recursively. Now, obviously, the quickest, easiest way to do this would be to simply take bunnies times 2 and return that result. But the whole point of CodingBat is to provide exercises to practice skills. And the entire purpose of this problem is to practice your recursion skills. So it specifically says that we want to do this without using loops or without using multiplication. Okay, so I'm afraid we're going to be a little tight for time with everything we've got planned today. So normally I would give you a couple minutes to try and work up a solution. I'm just going to jump to the final chapter of our little story here, and I'm going to show you the solution that I came up with. Okay, so when Mrs. Westerland walked us through recursive algorithms on Wednesday, one of the things that we specifically said we needed would be we need a base case, and we also need a recursive call. So our base case for this one would be if we call bunny ears and the number of bunnies is less than or equal to 0, we're going to return 0. Because obviously 0 bunnies would have 0 ears. Anything other than that, we're going to return 2, and we're going to add to that a call to bunny ears with 1 fewer bunnies than we started with. So if I call bunny ears with 2, I'm going to return 2 plus bunny ears with 1 bunny. Well, 1 bunny is going to return 2 plus bunny ears with 0 bunnies, which will then hit our base case and return 0. So with this code, when I press the go button, one of the great things about CodingBat is that it gives us multiple test cases. In this case, all of my test cases came up with green across the board, which means that my solution works correctly. If there had been any problem, maybe a couple of these would have shown up as red, and I would have to go back and do a little debugging. But in this case, everything looks good, and we're ready to move on. So I would click the next button, and it would take me on to the next problem. So again, if you haven't tried CodingBat before, that's just one of the resources that's out there. It's kind of a fun one to work with. I find myself getting a little addicted to it. You know, there are nights when I'm sitting and watching TV, and I have my laptop sitting in front of me, and I'll go out just to kind of refresh my own skills. There are some there's an AP category where you can do AP level questions. There are string questions, logic questions, array questions, all kinds of things out there that you can practice with. So if you haven't before, try this or one of the other resources that we've put out there. Okay, so just to kind of keep in mind, at the end of each review session, we'll provide info and resources to equip you to power up to go to the next level. And then we also wanted to just kind of quickly review our strategies, and then we'll get to today's stuff. All right, so keep in mind that our approach every day is going to be to keep things course focused, concept based. Mrs. Westerland mentioned that with the upcoming exam, one option is to do your code in writing on paper and then take a snapshot. So we're going to continue to focus on handwritten code, but we also want you to get some practice implementing code. So again, keep working on both of those skills. And as always, okay, my own students get tired of me saying this. I hope they're watching right now, and I hope they're nodding that yes, we get tired of hearing you saying this. Make sure you're taking your own notes. Make sure that as we walk through these things, you're getting you're getting some extra information as the information goes from your ears to your brain to your hand to paper. It's reinforcing the things that we're saying. So make sure that you're taking your own notes and developing those note-taking skills. Okay. All right, on to today's lesson. Today, we are specifically focusing on sorting algorithms. So prior knowledge, we're going to be sorting an array list. So implementation of an array list would be helpful. Again, if you missed the couple of live lessons we did on array lists, it might not be a bad idea to go back and watch those before going on. The other thing that might be helpful is a knowledge of how selection sort and insertion sort work. So in the AP curriculum, in the AP subset, there are 3 specific sorting algorithms. There's selection sort, insertion sort, and merge sort. If you haven't seen selection sort or insertion sort before, that's okay. Next week, as we start looking at ArrayList, we'll make sure we mention at least one of those, if not both. But today, because we're still kind of in this pattern where we're talking about recursion, we're going to focus on the merge sort algorithm and how you sort an ArrayList with merge sort. So to kick things off, we thought this would be a little fun and different. We actually have a video, and this was the one that we kind of hinted at yesterday. If you've already watched it, that's great. If not, we're going to show about an 8-minute snip. The entire video runs about 60 minutes or a little less. So,
and it is wonderful.
It is an amazing video. Mrs. Westerlin introduced me to this video. I had never actually seen it before, and now I'm hooked. I've watched the entire things through start to finish, actually twice. Mrs. Westerlin, I'm going to go ahead and start it, and then I'm going to stay quiet. I know we've had some issues with sound in the past, so if you hear something that sounds off that is different than what I'm hearing, make sure to please let me know.
Of course.
Okay.
Lots of types of algorithms have been created with the computer
I think we're better.
in mind. And some of the most important are sorting algorithms.
Yeah, I think we're okay.
Now, the job of a sorting algorithm is to put things in order, and they have lots of uses. For example, on the internet, information gets broken down into packets of data, which then gets sent across the web. Now, to reassemble that data, sorting algorithms are absolutely crucial to putting this data back in the correct order so that we can view the picture or read the email we've just been sent.
This is the System Development Corporation in California. It's considered to be the world's first computer software company. And it was here in 1963 that two computer scientists first formally wrote down one of the most iconic sorting algorithms of all time. It's called bubble sort. And here's an example of bubble sort in action, sorting blocks instead of numbers. It gets its name because with each round of the algorithm, the largest unsorted object bubbles to the top. Like all our algorithms so far, there's method in the madness. To see how this algorithm works, we're going to use it to sort 8 objects.
Now, the bubble sort algorithm says to consider the objects in pairs and swap them over if they're in the wrong order. So we're going to start at this end here and work our way to the top. So I consider these two, they're in the wrong order, so I swap them over. Consider the next pair, they're in the right order, so I leave them as they are. Consider this pair, they're in the wrong order, so I swap them. And we just continue doing this. Now the bubble sort algorithm says to go back to the beginning and repeat the process over and over again until the objects are in order. The algorithm stops when there are no pairs to swap round. So the bubble sort algorithm has successfully done its job. I've now got the objects perfectly ordered according to ascending height.
Bubble sort is elegantly simple and straightforward. But if the scale of the sorting task is huge, say organising vast swathes of data, then there might be better sorting algorithms for the job.
This is John von Neumann, the scientific genius who helped pioneer the modern computer, game theory, the atomic bomb, and, as it turns out, invented a sorting algorithm. He devised it to work on this, one of the world's earliest electronic computers, which he'd helped design. The algorithm is called merge sort.
The merge sort algorithm works on a principle of divide and conquer, and it consists of 2 parts. The first bit is the dividing part.
This involves splitting everything into smaller groups.
And now comes the conquering bit.
The groups are now merged back together. But as I merge the two groups, I compare the sizes of the objects one pair at a time so that the merged group becomes sorted.
Now, the merge sort algorithm might look rather similar to the bubble sort, but where it comes into its own is that with a larger number of objects, it's much, much faster.
So let's see how merge sort compares in speed to bubble sort. It's time for a battle of the algorithms.
Here we've got bubble sort on the bottom and merge sort on the top, and we've got them sorting 1,000 objects. Now, although they'll both produce the same end result, you can already see merge sort is getting there much faster. And this difference in performance gets more pronounced the more objects they're asked to sort.
What is the most efficient way to sort 1,000,000 32-bit integers?
Well,
I'm sorry. Maybe.
No. I think
that's not a.
I think the bubble sort would be the wrong way to go.
Come on, who told him this?
Merge sort beats bubble sort hands down for sorting large amounts of data. But in the crazy world of algorithms, there are many, many different ways to sort. At the last count, there were over 20 different types of sorting algorithms, all weirdly achieving the same result, but by different means.
So there's a bubble sort, there's merge sort,
insertion sort,
there's heap sort, there's quick sort,
Tim sort, we get gnome sort,
there's pigeonhole sort, which is also called radix sort.
There's bogo sort, which might never finish.
There's no such thing as the best sorting algorithm. Each has its own pros and cons. And which one gets used often depends on the specifics of the problem.
I think the beauty of studying algorithms is to try to aspire for solutions that are as elegant and efficient as possible.
Well, I actually think bubble sort's very pretty. I like it. Merge sort's beautiful.
We really couldn't live without them. Sorting algorithms bring order to the world. So far, we've seen algorithms.
You're back. I've got to figure out how to make it stop.
All right, well, I'm going to go ahead and jump in and
There we
steal
go.
the share back.
Please.
Okay, yeah, I love that video. I'm so glad you shared that with me personally and that we were able to share it with everybody, because I really think that's a great intro to what sorting algorithms really do. I do want to reiterate, though, that they talk specifically about two different sorting algorithms, bubble sort and merge sort. And bubble sort's not part of the AP subset. That's not something that would normally be required to be covered in an AP course. But I am kind of glad they threw it in. I mean, it's kind of a nice intro to sorting algorithms and explains really one of the simplest algorithms to execute and to implement. But then it also goes on and explains merge sort as well. So let's go ahead and jump into merge sort. We are down to about 15 minutes, so I'm gonna have to watch the time here. So when I cover merge sort with my students, we typically take 3 class days to go through merge sort. I give my students kind of a high level description of what it does and a demo. Day 2, anybody that didn't really figure it out the night before, I share a little more detailed pseudocode of how the algorithms work. And then on day 3, if there's still somebody that's struggling, then I sit down with that small subgroup of students and we look at the actual code. We take a list on like an array list on paper, and we trace through the code step by step, line by line, and actually break down what the algorithm does. So I'm going to kind of essentially do the same thing with all of you today, even though, again, we're down to like 15 minutes left. So the first thing I'm going to show you, for this implementation of merge sort that I'm going to show you, there are actually 2 different methods involved. One of them is merge sort, and the other one is merge. So in the video, he described merge sort by saying that it's a divide and conquer, and that's exactly what these 2 methods do. The merge sort method divides, and the merge method conquers. It puts them all back together again. Now, like I said, on day 1, I really just give my students kind of a high-level description of what each one of these methods do. But the merge sort method itself is pretty straightforward. I mean, the high level description of what it does is really close to what the code does. So even though I try not to give them detailed pseudocode, this is about as basic as you can make merge sort. We pass in an array list, we pass in a low index position and a high index position that we want to merge sort everything in between. And as long as our low value is less than the high value, we find the middle, and we immediately call merge sort on itself with just the left half of the array list. And then we receive that one, and as long as low is less than high, we recall merge sort again with the left half, and we continue to break things into smaller and smaller pieces. So this is the divide part. This is the part where we implement recursion, we call merge sort in itself, and we keep breaking our list that we're sorting into smaller and smaller and smaller pieces. And then we get to the conquer part, where after we've broken things into the smaller pieces, we merge them back together again. And this, like he said, is where the merge sort algorithm kind of comes into its own, or in my words, it earns its pay. This is where the majority of the code comes from. Oops. There we go. So like I said, you couldn't even really call this pseudocode. This is a basic high-level description of what the merge method does, okay? The first thing that happens is and I'm going to pull up a little example here. We call our merge method. And the other thing I want to point out is that it's, in my opinion, okay, the way I handle it with my class is it's easier to explain what the merge method does later in this whole process than earlier. The very first merge that would actually take place if I ran the code would be to merge these 2 values back together again. We break our list in half, break it in half, break it in half, till eventually we've got the value at position 0 separated and the value at position 1 separated, and we merge those back together. But it's not really very effective to see what this part of the algorithm does with just 2 separate blocks. So I found that it's easier to kind of explain what merge does if you look at the last merge to take place as opposed to the first. So this would actually be the last thing that happens to finalize putting our list back in the correct order. And I hope it will kind of make sense as we go. So when you call the merge method, the first thing that happens is we're going to create a copy of the original elements to a temporary array list. Voila, there we go. Okay, and then I know the computer doesn't care, Java doesn't care, the compiler doesn't care, but me as a human being looking at this, it makes it a little easier for me if I think of this temporary array list as 2 separate virtual array lists. So I'm going to kind of break them apart, and as I'm thinking about this algorithm, this is how I'm going to picture it in my head. So even though it's still one array list that goes from position 0 up to 7, we have 8 elements, I'm going to kind of picture it as 2 separate halves. Okay, then our algorithm is going to be to work from left to right in each one of our little virtual array lists, and we're going to use variables to keep track of which values we're looking at. And I probably should have specified in here, we also need a variable to keep track of a placeholder in our original array list, because we have to know where we're going to put things back. The next step is going to be to compare these 2 elements, the 2 elements that we're looking at in our 2 little virtual array lists, and we're going to return them back to the original array list in the correct order. So as we start looking at these 2 elements, 1 is less than 3, so 1 is going to be moved back up to the first position in our original array list. And then we're going to continue to loop through this until we get to a point where we can stop. So the next step would be to work from left to right in each of our virtual array lists. And notice I also have to increment the placeholder that I'm using to keep track of where I am in my original array list. But I'm going to move from position 4 up to position 5 because I've already taken care of the 1. So now we're going to compare our elements so that we can return them to the original array list in order. And in this case, 2 is less than 3. So the 2 is going to get moved up to the placeholder position in our original array list. And we're just going to keep that process going. We're going to work from left to right in each virtual array list. We're going to compare the elements. The next comparison is going to show that 3 is less than 5. So now we're going to pull from the left-hand side of our temporary array list, and the 3 is going to move up to the placeholder spot. And that process is just going to continue. I'm going to go ahead and fast forward here just a little bit. Let's see, we're going to work from left to right. We're going to compare the two elements. 4 is less than 5, so 4 will move up to our placeholder. We're going to continue to work left to right in each virtual array list. We're going to compare the elements. Now 5 is less than 6, so 5 will move up to the placeholder. Let's see, we're going to work from left to right. We're going to compare the elements. 6 is less than 7, so 6 moves up. Moving from left to right, comparing the elements, 7 is less than 8, so 7 moves up to the next spot. And this is where we kind of get to our stopping point, okay? We're going to continue to work from left to right, but now look what happened down here in our temporary array. The variable that we're using as a placeholder to keep track of where we are on kind of the right-hand side of our temporary array list has now gone out of bounds. Okay, it's now pointing us beyond the size of this temporary array list. So that's our signal to stop. If I were to go ahead and compare elements and go on into this loop that we've kind of started to visualize here, I'm going to compare the element at position 3 to an attempt to compare to an element at what it thinks is position 8, but there is no position 8. That's where my variable is now pointing me at. So we would get an index out of bounds exception. So that's our signal that we stop this loop. If at any point this value goes beyond mid, the middle value that we passed in, or if this variable goes beyond the size of our array list, or I should say high, if whatever we designated as our high position, then that's our indication that we stop. But notice that we still have some things unaccounted for in the left-hand side of our array list. So the other thing I point out to students, and I don't show them this part because again, I want them to figure some of this out on their own, that if by some chance the right-hand side of our temporary array list finishes first, then we have to include a little something down here at the bottom to pick up the pieces, to pick up the leftovers from this left-hand side. So the last thing we would do is we would say, okay, we're totally finished with the right-hand side. We need to pick up the leftovers, so we'll copy 8 up into that position. Okay, so that's a very quick demo of our merge sort. Now, what I'm planning for the power up for tonight, give this a try over the weekend, or I should say the power up for the weekend, give this a try over the weekend and start with just the description that I've given and see if you can flesh out the code for a working merge sort. If you get to a point that you feel like you're kind of spinning your wheels, then go the next step. Out in the shared folder that we're sharing things with you, I've put a PDF that contains a pseudocode hint for the merge method. And the pseudocode in that is much more detailed than what you're looking at here. So then take a look at that pseudocode and see if you can work out the details. And if you still look at that and you're not quite figuring it out, that's okay. Then go on, and also in the shared folder, you'll find a Java file that contains working code for merge sort. Take it apart piece by piece, look at each line, maybe take a piece of paper with 8 items in random order, 8 numbers in random order as your array list, and work it through on paper and trace it very slowly, very carefully, one line at a time so that you can see what the actual algorithm does. Okay, that's our lesson for today. Let's do a quick check for understanding. There wasn't really, I mean, normally this is where I would let you do some coding, but again, I know it's going to take a little while to kind of digest what we just looked at and come up with merge sort code. So I thought I would do a little true or false check for understanding today. Okay, so the first question I have, true or false, merge sort and bubble sort are the only 2 known sorting algorithms. Hopefully your answer to that was false. In the video we watched, the video said that there are more than 20 known sorting algorithms. And again, it would be fun to try and rattle them all off. But I do want to reiterate that only 3 of those more than 20 sorting algorithms are part of the AP subset. We have selection sort, insertion sort, and merge sort. Those are the only ones that we really need to focus on in this course. If you go on and take a college level computer science class, I know when I was an undergrad, I had to take let's see, it was analysis of computer algorithms with Dr. Gupta, and we spent the entire semester looking at all of the different sorting algorithms and breaking the algorithms down and measuring efficiency and learning cool things like that. So you'll get the others at some point, but in this class, we're only looking at those three. Okay, bubble sort is not part of the AP subset. Okay, merge sort and bubble sort are equally efficient. I don't know if you can see Mrs. Westerlund or not, but she's shaking her head no. That is absolutely correct. That is false. Merge sort and bubble sort are definitely not equally efficient. In fact, in the video, we saw a side-by-side comparison, and bubble sort had barely even started and merge sort was already finished. So merge sort is much, much more efficient. The merge sort algorithm is designed to implement recursion. That is a true statement. Merge sort is definitely designed to implement recursion. And our final question, the merge sort algorithm splits a list into pieces, then merges them all back together. That is also true. The splitting the list into pieces, that's the recursive segment, where we recursively break our list into smaller and smaller pieces. And then we have a method which uses iteration and looping to merge them back together again. So that is our intro to merge sort. Just a quick debrief and summary. There are a wide variety of sorting algorithms. The three that we focus on in this class are selection sort, insertion sort, and merge sort. Merge sort is the one of those three that's designed to use recursion. Okay, and merge sort specifically works by recursively splitting a list into smaller pieces and then putting the pieces back together again in order.
And I was going to add, sorry.
No, go ahead.
Next week, we're going to be doing 1D arrays all week long. So they're going to have good lists of data to apply their code that they're going to work on this weekend. And if they worked on binary search yesterday, or if they've worked on some algorithms in the last 2-3 days, they're going to have some good places to apply it.
Yeah, because that's good to point out, because the algorithms that we've looked at over the past couple of days, we focused Monday and Tuesday on array lists, but then as we've talked about, binary search, linear search, the other sorting algorithms, merge sort even, all of those can be applied to either arrays or array lists. So our focus has been array lists up to this point. Next week is where we start getting into the array side of things. So. Okay, so our resources for you to power up. Remember that you can find those at bit.ly/CSA_exam review 2020. And just remember that bit.ly links are case sensitive. So our power up for this weekend, again, the lesson resources from the CED are always very helpful. Runestone, Practice It, Coding Bat. But the main thing that I'd like you to think about over the weekend, see if you can apply the merge sort algorithm to an array list that you've created this week based on Monday and Tuesday's lessons, okay? See if you can get merge sort working, and then once you have it working for an array list of integers, go back and try and apply merge sort to an array list of dogs or horses or animals in general. Think about what you would have to do to try and sort an array list of dogs based on their name using the get name method that we talked about earlier in the week. Okay, and again, there are a lot of video resources that are out there. Bill Barnum's YouTube channel on recursion, Cody Hendrickson's YouTube channel on recursion is fantastic.
They're both fabulous teachers.
They are excellent, very well-known teachers.
And nice guys.
Yeah. Yeah, I have to admit I've never met Bill, but I know Cody fairly well, and he is also my AP reading running coach. So so when we go running at the AP reading, he's always there to coach us along and keep us all pepped up and moving. So shout out to Cody. Hi, Cody. There's also the YouTube video, the one that we watched today. I would encourage you to go back and watch the entire hour-long video. It is absolutely phenomenal. And then again, if you haven't looked at them already, take a look at the sorting algorithms that are available, the visualizations and videos that are there. Okay, and let's see, I will let you pick up from here if you'd like.
Yeah, so please send us your information. Send us artifacts, send us helpful hints. If you work through something and solve a question or solve a problem, we love hearing that too, and we'll brag about you. So tell us that. And there's the link.
Oh, it looks like some of our pictures might have gotten
No, it looks
mixed
good.
up in
It
here.
looks good. It looks good. Oh, I see what you're saying.
Yeah, I think we've
That's
got some
funny.
duplicate pictures thrown in.
Okay, well, Gwendolyn
I
has
didn't
a
notice that
cat.
before.
It's a really pretty
Oh
Persian.
no.
I remember the picture of her cat. So Gwendolyn, we'll get your cat on there on Monday. So I love San Juan, Puerto Rico. I'm gonna have to drop a pin if I didn't already. I don't think I did. So that's exciting. Cecilia in New Jersey sent us the brackets. I'm definitely the right-hand side of the two types of people.
Sorry, I'm more of a
I know
left.
you're the left. See, there we go. We
Yep,
make a
we
complete
complement each other
pair, so
well.
that works. I'm figuring that Olivia's teacher in New York probably does the debugging with the rubber ducks. We might do some rubber duck ArrayList in a couple of weeks. So thank you all for sending. Oh, I see Mr. Lemon's got duplicated too. Who
Yeah.
knows what's going on?
Yeah, I don't know what happened.
Dennis's
That's odd.
dog is a poodle. I'll fix that on Monday too, but it's like a standard poodle or maybe a poodle doodle or something, sitting on a couch. I remember that. So, all right, shout out to our CS principals. They have videos to go over the 2 performance tasks. So please let your friends know. Text them, Snapchat them, whatever it is that you do. Mr. Bonarigo and Miss Alano are going to be adding another one on Monday, and they already have the Wednesday ones up on their YouTube channel. They have their own playlist. So we're happy about that. And we hope that everybody in principals gets their work in. Please, 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 you now know the importance of having your device situation taken care of by May the 15th. So if you are listening to us and you only have a cell phone or you only have a tablet, you should go on that cell phone or tablet to cb.org/tech and let College Board know that you have, maybe less than the number of devices you would have in your schoolroom. And there are places that have committed to help you and to get you prepared and equipped for your examination. So please take advantage of that resource. And that is it.
That's all we got for today.
That's
all we've got for this week.
Went fast. So
yeah, it has.
Thank you for being here with us. Come back Monday. We're going to do Unit 6 from scratch, 1D arrays, and it'll be a great week.
Yep. Come back and see us again. Everybody have a great weekend.